Hello, and welcome to episode 34 of the Brain Cancer Podcast. First off, I do want to say thank you so much for taking the time to tune in and listen to the show. Quite a hot day up here today, and in the next couple days, it's going to be even hotter. But I was out earlier, and I will go back out later. But during this part of the day, I wanted to sit down and record our July news recap episode. There were a few stories which, as usual, came out closer to the end of the month, which is why I always like to hold off on recording until a few days into the following month. We also had Glioblastoma Awareness Day on July 20th, and I did put out a short episode for that, so if you haven't listened to it, go back and give it a listen. I'm really trying to stick to our 2 episodes per month, and I really want to record one possibly in the next couple weeks about dexamethasone. That's a very important topic as well. Personally, I'm feeling fine, doing fine. I cannot believe how quickly this year is already flying by. We are already in August. However, the good thing is that my favorite time of the year, the autumn season, will be upon us within a couple months. I do really love and appreciate every season that we get. There's something about the fall or autumn season which I always really enjoy. Summer is really nice, but it can be difficult when it's 99 degrees Fahrenheit outside and it's feeling like 110 Fahrenheit outside. I like to wear hoodies, and you can't exactly do that in that type of weather. Before I get off on too many other tangents, let's get into the news. We are actually going to start off with an article titled simply Detecting Brain Cancer. This particular article was put out by Harvard Medical School and Mass General Hospital, where I do get all of my treatment. Researchers at Harvard Medical School and Massachusetts General Hospital, who previously developed a blood test for mutations in a gene linked to gliomas, the most common type of adult brain tumors, have now applied their technology to detect additional mutations in the gene that codes for epidermal growth factor receptor, or EGFR. We do know that EGFR is a very important mutation in our diagnosis. We're still learning more about it, but this is yet another step forward. The advance, described in a study published in Clinical Cancer Research, provides clinicians with a powerful tool to detect the presence of gliomas, characterize the tumors, and monitor their status after treatment. The team's test is a form of liquid biopsy that detects pieces of tumor cells' genetic material called mRNA circulating in the blood. The previous study first reported the technique, a highly optimized novel digital droplet polymerase chain reaction blood test, accurately detecting and monitoring the presence of 2 mutations of the gene TERT, which is commonly mutated in glioma tumors. We can also just refer to this as the TERT mutation. After further tailoring their technique to detect mRNA produced by the mutated EGFR gene called EGFRV3 that is often present in especially aggressive gliomas, the investigators determined the presence of EGFRV3 mRNA in glioma tumor tissue from 37 tumor tissue samples and tested their blood in plasma samples from 30 patients with gliomas with tissue confirmed EGFR3, 10 patients with gliomas with no EGFR mutations, and 14 healthy controls. The team reported that the blood test had an overall sensitivity, the ability to detect the presence of EGFRV3 of 72.8%, and a specificity, the ability to detect the absence of EGFRV3 at 97.7%. Quote, "There is a real need to make brain tumor diagnoses less invasive than the current technique of tissue biopsy. This research demonstrates that it is now feasible to diagnose a brain tumor via blood test for one of the most common mutations detected in brain tumors, said co-senior author Leonora Balaj, assistant professor of neurosurgery at HMS and an investigator at Mass General's Brain Tumor Research Center. The technology could also be used to determine which patients are most likely to benefit from drugs targeting the EGFRV3 protein on cancer cells. The technology could also be used to determine which patients are most likely to benefit from drugs targeting the EGFRV3 protein on cancer cells. Quote, current studies involving CAR T immune cells are aimed at targeting this surface marker. A blood-based assay for EGFRV3 would allow researchers to stratify patients who would be eligible for potential clinical trials, as well as monitor the response to the therapeutic using a simple blood test, said co-senior author Bob S. Carter, the William and Elizabeth Sweet Professor of Neurosurgery at HMS and chair of the Department of Neurosurgery at Mass General. The scientists noted that their EGFR and TERT tests will require additional studies to evaluate their performance in larger groups of patients, however. The scientists noted that their EGFR and TERT tests will require additional studies to evaluate their performance in larger groups of patients. However, they said combining different mutation assays represents a promising strategy to more accurately diagnose gliomas, monitor tumor progression, and assess response to therapy. The technology could also be applied to a range of other cancer types that carry mutations in these and other genes, they said. Now, back when I was diagnosed and was at the beginning of the clinical trial that I did, I actually participated in, I'm not sure if it was this one, but I did participate in a trial where they took additional vials of blood with the goal of being able to create blood-based tumor tests, essentially, where they would be able to do what they said in this article. I don't remember if it was over multiple weeks, but I had definitely signed up and given blood at one of my usual appointments, which was specifically for developing a blood test for brain cancer. It makes me really happy to see that we are coming along in our treatments now, that we can not have to just biopsy a tumor, and a simple blood draw could be a very reasonable approach, far less invasive and overall safer for the patient. Next up, brain cancer therapy shows promise in pediatric clinical trial. A new antibody therapy for children with medulloblastoma has shown promise during a phase 1 clinical trial. The antibody, which targets a protein that enables cancer cells to multiply and spread, was well tolerated and helped to stabilize the disease, helping to preserve the patient's quality of life. The trial was led by researchers at Atrium Health Levine Children's Hospital in Charlotte and MGH here in Boston. I didn't intentionally try to find MGH-based articles, just in case you're wondering. They do a lot of work, though, and they're a research hospital, and I wanted to highlight this particular article. Medulloblastoma is the most common type of brain cancer in children. These tumors are known to be aggressive, growing quickly, and having the potential to metastasize to other areas of the body. Relapsed and refractory tumors are especially challenging after the standard treatments of surgery, radiation, and chemotherapy have failed. The trial enrolled 15 children with relapsed or refractory medulloblastoma that did not respond to standard treatments. Patients received increasing doses of the antibody TB403, and all patients received 2 doses of TB403 in the first cycle of treatment. the maximum tolerated dose, defined in clinical trials as the highest dose of a drug that does not cause unacceptable toxicity, was not reached. Importantly, although there were no significant reductions in tumor size, 7 of 11 patients in the trial experienced disease stabilization, or stoppage of progression, and which persisted for more than 100 days in 4 of those patients. Disease stabilization may have been caused in part by chemotherapy, which was re-added for some of the patients. Quote, these findings indicate that treatment with TB403 should be tested in larger clinical studies of children with advanced medulloblastoma and perhaps at earlier stages in combination with standard therapies, said lead and corresponding author Giselle L. Saulnier-Scholler, MD, director at the Isabella Santos Foundation Solid and Rare Tumor Program, and chair of the Beat Childhood Cancer Research Consortium at Levine Children's Hospital. Currently, there are no treatments for relapsed medulloblastoma, and the survival rates after relapse are low. Of note, subjects in the study were at home while in treatment, with few hospital admissions, which is critical for preserving quality of life when additional time with family is often the goal of therapy, wrote the authors in the article. The antibody TB403 recognizes placental growth factor, or PLGF. The MGH research team previously showed that PLGF and its receptor neuropilin-1 and RP1 are often overexpressed in human medulloblastomas and are required for its growth and progression in mouse models. That work also demonstrated that blocking the PLGF NRP1 pathway in medulloblastoma models carried tumor regression, decreased spread to the spinal cord, and prolonged survival. Beyond the new biological insights, the experimental results were particularly exciting because blocking PLGF, unlike other cancer-related pathways, was safe in humans and thus was a particularly promising strategy in the pediatric population, said senior author Rakesh K. Jain, PhD, director of the Steele Laboratories for Tumor Biology at MGH and the Andrew Work Cook Professor of Radiation Oncology at Harvard Medical School. We are thrilled to see the initial translation of these concepts into a clinical trial. Our third article for the day is titled A New Path for Treating Brain Cancer with a Yale-developed compound. Yale researchers have developed a new class of molecules that target some of the deadliest brain cancers while sparing healthy tissue along the way. The discovery, which combines innovative synthetic chemistry and cutting-edge mechanistic studies in molecular biology, offers a potentially powerful new approach to treating drug-resistant glioma tumors that form in the brain and spinal cord. A study describing the findings appears in the journal Science. Quote, a major problem in treating gliomas is that the patients can rapidly develop resistance to the drug temozolomide, which has been the backbone of most glioma treatments for over 20 years, said Dr. Rajit Bindra, the Harvey and Kate Crushing Professor of Therapeutic Radiology at Yale School of Medicine. I do want to interject that technically temozolomide has not been the backbone for over 20 years because it was only approved 16 or 17 years ago. We'll let them slide there. Resistance arises from acquired genetic mutations that essentially make the drug invisible after about a year, leading to recurrence and death in most cases. For example, the 5-year survival rate for patients with glioblastoma is 5%, added Seth Horzon, the Milton Harris 29 PhD professor of chemistry in Yale's Faculty of Arts and Sciences, and the study's other co-corresponding author. We set out to identify new agents that can overcome acquired resistance to temozolomide. There are an estimated 20,000 new glioma cases diagnosed in the U.S. every year, more than half of which are glioblastomas, the most aggressive subtype. It is the most common type of malignant brain tumor among adults. Many cancers, including gliomas, are characterized by defects in DNA repair. For reasons that are not well understood yet, a specific DNA repair protein, known as MGMT, is lost in more than half of gliomas. Bindra and Herzon's new class of molecules exploits this DNA repair defect. Their lead compound generates a specific form of DNA damage known as interstrand crosslink that is highly toxic to cells. While many agents that generate interstrand crosslinks are used in the clinic for patients with cancer, most cannot discriminate between healthy tissue and tumors, leading to significant dose-limiting toxicity. The newly developed compounds selectively generate this DNA damage in tumors, but not in healthy tissue. In essence, we have created a tumor-selective DNA cross-linking agent. The discovery is potentially applicable to other types of tumors harboring specific DNA repair defects, a line of inquiry the researchers are pursuing. Our discovery essentially redefines the rules on how to target cancer cells, Bindra said. Herzon added, "We are incredibly excited to test whether this can be broadly implemented as a therapeutic strategy for many subsets of cancers with DNA repair defects in the future." The researchers said they expect their lead molecule to be rapidly translated into the clinic owing to its structural similarity to temozolomide. That similarity will enable Bindra and Herzon to accelerate the evaluation process, often referred to as the IND enabling studies, which is required by the US FDA prior to testing in phase 1 clinical trials. They said the clinical trials for these new compounds could begin as early as 2024. I think this is great because we do know that so many types of brain cancer and the different brain tumors, they quickly become resistant to the temozolomide. As of right now, it really is one of our best options. We know it works, but it doesn't provide lasting benefits. And once the tumor becomes resistant to it, it's not going to be of any benefit at all. And then the patient is just stuck with having to deal with all of the negatives and receive no benefit from it. This is why we need more clinical trials and more options that can cross the blood-brain barrier and be effective. Our final story of the day, I wanted to talk about this short story that I saw that only happened a few days ago. This was posted on July 29th, and I just really wanted to talk about this because it's not fair to see any kids having to go through something like this. I'm fine because I had my childhood and I know what's going on and it's fine by me. Not fine, but I understand what's going on and I got to do the things that kids are supposed to do. This was down in Knoxville, Tennessee at the Children's Hospital. It was the moment one Knoxville boy had been waiting for more than a year, his chance to meet Batman following cancer treatments. Trish Adams said it started last summer when her 5-year-old son Chance started getting sick daily. It reached a new height shortly after the 4th of July as they rushed to East Tennessee Children's Hospital. After several scans and tests, the medical team found an aggressive form of brain cancer. Chance had a large tumor, and they knew it would be a long road. That's when a friend reached out to Batman, Chance's favorite hero, for some words of encouragement. Batman immediately made a video message of encouragement just saying, "I know the odds are not in your favor, but tough things make us stronger," explained Adams. "When you finish your treatment, which we know you will, I'm going to come to Knoxville and give you a ride in the Batmobile." That's exactly what happened Friday morning outside East Tennessee Children's Hospital. Adam's telling the news team that he is done with treatments for now. The family has been in and out of St. Jude's in Memphis since his diagnosis last summer. Chance's mom also said meeting Batman and getting to sit in his famous ride was some of the best medicine they could have asked for. His next big adventure is starting kindergarten this fall. It just breaks my heart when I have to see kids going through anything like this. It's just not fair. I don't know, I may have mentioned it before, but right when I was getting my radiation mask made, I was in the waiting area and there was this poor little girl. She was 5 or 6. I'm not the best at young ages because I don't have kids, so I don't really know. But she was in her pretty little princess outfit. She had a wand and her tiara, and she had lost all of her hair already from going through the treatments, and she would not leave her father's side. And she was getting all of the attention from everybody in the room, but she still looked so scared, and it was just heartbreaking, really. Even though she was getting all of this attention and people telling her how pretty she was, you could tell she was still just really scared, as she should be, as you would expect. 5 years on, all I can hope is that she is completely cured and actually having a great childhood and spending it with her friends, going to school, playing outside, doing all of those things. I know I always try and end these news recaps on a positive story, and I could not pass up a chance to talk about a kid getting in the Batmobile and going for a ride with Batman. I do think we're going to wrap it up here, and I want to say thank you so much for taking the time to tune in. I really enjoy doing these. I really enjoy researching articles, and it really helps me mentally and is a great way to just focus and get away from everything for a little bit and just sit with my headphones on and work on an episode. I guess it's like because I'm also talking to all of you, and that really helps me as well. And all of you reaching out to me means more than you'll ever know. It really makes the world of difference to me. I have more ideas for more episodes, and I cannot wait to share some of them with you. You can follow the page on Facebook at facebook.com/braincancerpodcast. I post there every single day, and you can always send me a message on there as well, or send me an email at braincancerpodcast@gmail.com. You can follow on Twitter at twitter.com/braincancerpod. Be sure to subscribe or follow the podcast on whatever app you use. Maybe write a review. Not all of them have that, but if you want to, then go for it. I just am so appreciative of all of you. We will be back soon with another episode. Thank you for everything, as usual. Hope you all have a great day or night, and I will talk to you again soon. Bye.